Okay. Am I audible and is my screen visible?
Yes, you are audible and visible.
Okay, awesome. Cool. So today, just let me give the brief overview of what we're going to talk about. So we are going to talk about observing the derived state. So basically, in this chapter, we have mainly discussed that we have some original data, and in most applications, in most scenarios, we need some derived data out of that original data, right? And that derived data helps us to read and make queries faster, right? So we are going to see the relationship of where our original data lives, where our derived data lives, and what is the relationship between the write path and the read path, right? So this will talk about that, observing the derived state, right? And we will see some examples of that. Then the last two sections in this chapter is aiming for correctness and doing the right thing. So aiming for correctness talks about this philosophy that when we are building our data systems, which take the original data and then processes it and creates an output out of it, uh, we have to be sure that that derived data system is consistent, it is correct. If it becomes inconsistent at some point of time, then we will be providing wrong information, right? So we will be talking about what are the things that can go wrong when maintaining these derived data systems and how can we make sure that they don't become wrong. And we might think that we have built our systems correctly and they will work correctly, but when we will discuss this section, we will see that there are so many things that we often forget about when building these systems, and which later proves to be the pain point to us, and in the form of bugs and other issues when we start using our systems, right? The last topic, doing the right thing. This topic is more about morals and ethics that basically overall in this data systems we are utilizing in a lot of situations we are utilizing users data to make some decisions, right? And users data is valuable, so we have to be very careful about how we are dealing with users data, and lot of times we can introduce some biases and other stuff when dealing with users data. So we will see what are those issues that can arise and how we can be individuals who can ethically and morally deal with users data, right? So yeah, so let's begin. So starting with observing the derived state, right? So there is this very good diagram in the book. So let's say we have an application which is building a search index, right? So the right path would look something like this, that you would have application server which will where these documents will be living, and whenever any updates are made to those documents or new documents are added, then this component linguistic analysis will run. It will analyze those documents, create the index, and finally we will have search index in some of the nodes on our application, in our application server, right? So overall, this is our right path, that taking those documents and creating an index, right? How would the read path look like? The read path would be that the user is searching for a query and finding the relevant documents from the key terms, right? So again, the request will be hitting some other component of the application server, and basically there will be this query processing engine, fan out engine, and things like that, which will find where those documents are in the index, and it will return those results to the user, right? So this is the read path, right? So basically, we can say this right path is any pre-computation that we are doing so that we can retrieve the results easily when we want to read the data, right? And read path is basically retrieving the data that someone has asked for, right? And our derived data, whatever derived data set that we are building, it is an intersection between the read part and the write part. So when we are saying that we have some original source of data, which is documents, and we are building a search index out of it. So this search index is our derived data, right? And it is intersection of write path and read path, right? It is built by doing some steps on the write path. It is read by doing some steps on the read path, and it is basically that intersection, right? So and now now the interesting way to look at when we have this diagram in mind is that if we want, we can uh, like stretch this right path more closer to this user, right? And then what will happen is the read path will become smaller, right? But then write path will become longer. Or we could uh, make the right path stretch and go all the way here. Then the right path will be smaller, but the lead path will be bigger. So, for example, uh, the scenario of making right path longer is that, let's say we have built out for every query, uh, we have built out that what will be the documents that should be returned, right? So then basically this part was executing when a query was executed and those documents were returned. But instead we have iterated over all possible queries and already stored all the documents in at some place, right? So our write path has extended all the way where we have documents pre-ready for you. If you just provide us query, we will immediately give you that, right? So that is so then the right part becomes much more expensive, right? And maybe it's not feasible also because you would then have to compute for every search query, right? But then the read part becomes extremely short, right? The example of extending the read path is that you don't index your documents at all. So you just have your original source of documents. Then whenever if user searches for a query and you have to find matching documents, then you have to iterate over all the documents. You have to do grep on all the documents and find out what are those relevant documents that matches that search query, and then return those documents, right? So now you have extended the read part all the way, right? So now your read path is expensive, but your write path will become cheaper, right? So this is what it has been talked about. And the middle ground in this case is that you are using some kind of cache, right? So rather than pre-computing your search results for every query, you are only storing the search results for frequently used queries in the cache, so that at least for those scenarios, the read path is small because you have pre-computed them, right? So that is a great middle ground that someone can build, that they can use cache and basically make the read part smaller in that case, right? So that is this. So yeah, so these topics mainly are some examples of this right path and read path, right? One, that we have a materialized view and we are doing the caching, right? And I have already talked about this full text search index. Extreme right path is pre-computing, extreme right path is having no index, and middle ground is cache, right? The other example of this thing is stateful offline capable clients. So these days we have a lot of apps which work offline as well, right? Because generally on your mobile you have your mobile networks are flaky and they don't have so much bandwidth. So you need to build applications which are offline built as well, right? So in those scenarios, uh, you generally have a local database of some functionality of your app inside the user's device, and that local DB is the cache of the server's state of the system, right? And basically, so this local cache is a derived data, right? And it lives locally on the client and it needs to be synced whenever it becomes online. So again, it is this kind of example of how you're using derived data to build
So
more.
Abhishek, locally we are storing in a cache that user already searched for that, right?
So, yeah, so the first example I was talking about was search index. This stateful offline capable client is not about just search, but any application. Let's say any news feed application. Let's say you are building a news feed application, right?
But
So
but the value that user never searched, then how we can get from cache?
yeah, that won't be stored in cache. So only the frequently searched data will be in the cache. And the value which user has not searched for, then you would have to go through this entire path where you will look at the search
But
index.
at the time offline, then we will not get any result, right?
Yeah, in that case, we won't get it.
Yeah.
Yeah,
Okay.
definitely. So uh, then the other example where we are we are basically moving the data to clients, right? Whatever data we have, we are proactively moving the data to the client is. Uh, so basically, in typical web page, if you load a web page, it does not automatically update, right? But like these recent protocols, like WebSocket, right? They allow a client to open a connection with server, then server can actively push messages to client, right? So in this case, a server can actively push any changes to client, and that also means that the right path, right? This right path that we have seen, it is basically from application. If any change was made, it is sent all the way onto the client's machine on the client's web browser, right? So this is one more extension of right path that you have extended the right path. So basically, if you are observing live cricket score, as soon as your live cricket score was updated, you are all the way, whatever client has opened this WebSocket connection, you are pushing that change, you are making that right all the way to on that client's web browser, right? So that is another example. So yeah, and then this end-to-end event streams, right? Basically, we see that instant messaging in online games, where again, this is example of about thing that whenever someone is making a change, it is pushed all the way. That message or that online game is pushed all the way immediately. Like it is not that first it will be stored in server and then later when anyone will query, then only it will be returned. It is actively, proactively pushed all the way to the other user, right? And that we see in the form of like instant messages and your online games getting updated immediately, right? But we will see that most applications are not built on this proactive way, right? They are based on request response way, that you will request for something and you will get the response instead of this proactive manner. And the reason for that is like most of the data systems that have been built are built on the stateless request response interaction model and the published subscribe model. But this published subscribe model is also one of the way of building your data systems where you're immediately pushing your whatever your data changes all the way to the clients, right? Instead of client requesting for that updated message and then he getting a response, right? So yeah, so this is pretty much about this. Then the last thing in this was reads are events too. So another thing to consider building these applications is that your reads are events as well, right? So in some scenarios, you would want to capture your leads as well. For example, example given in the book was, let's say in online shopping, you were looking that you read that when this item will be shipped, and based on that, you actually made a decision to buy that product, right? So now that application should know that you have read this value, and that's why you have made the decision, and should probably store it somewhere in the system uh, and treat it as an event, right? Or otherwise, let's say I opened a web page, I read that it will be shipped in one day, but when I was actually making a buy, by that time there has been delays and now the product is being shipped to me in 4 or 5 days. That is not a good experience for me, right? So it should have noticed that I have read the value of 1 day, and then for me it should have shipped the product in that time, right? Or while making a while making the purchase of the product, it should have notified me that now the shipping time has changed, right? So to do all that, your data system should have recorded the read event as well so that it can make these decisions, right? So that is one another thing. So yeah, so this was about observing derived state. Then now we are moving to a different topic, which is observing aiming for correctness. Before we move there, any questions or anything anyone wants to add? Am I audible? Cool. So this topic is quite interesting, and I will I can give some examples also of this, my own experiences. But let's start. So aiming for correctness, what it means is that, so basically one one are these stateless services, right? Where we only read data. So in these stateless services, if something goes wrong, you can just restart, fix your big rerun, and everything is fine. Nothing was stateless. But these databases and stateful services, right, where you are storing some information, there, if because of some bug or some issue, if you have stored wrong information, then that effect will potentially last forever, right? If you are just fixing that bug, it will not automatically save all the previous wrong database commits that you have made or wrong information that you have saved, right? So let's say if you have to apply some tax and if you did something wrong over there, until and unless you explicitly fix the mistakes that you have done, it will not get automatically fixed, right? So this is one of the issues with stateful services and databases, right? And when we're building applications, it is very important for us to build reliable and correct applications. So one of the ways that the applications have been have been relying on building reliable and correct manner is using ACID, right? The database provides ACID guarantees, and with ACID, they can say that like whatever transaction they have done, that at least whatever intention they have told to the database because of ACID, that intention will be done properly, right? But nowadays, as we have seen in previous chapters, there are various weaker guarantees as well, right? Where we don't have strong properties of ACID, we have weaker guarantees. And those were made so that we get better performance and scalability. So in those scenarios, there are even more chances of doing mistakes and making incorrect applications, like doing something wrong. And so there we have to be very careful about the correctness, right? Other thing which is mentioned in the book is consistency is often misunderstood, right? So we always talk about gap and we say that so we can embrace weaker consistency for the sake of better availability, right? But people don't actually understand what is the meaning of weak consistency, right? And like just to highlight that it means it will be eventually consistent, right? It should not be that it is inconsistent, that it is never becoming inconsistent. So cap by C, if we are not going with C, that does not mean we are making inconsistent system. That means we will make eventual consistency. So that is something to be careful about. And then the other thing is like these databases provide various isolation levels, right? Which we have discussed in previous chapters. Uh, and although databases would have implemented these isolation levels correctly, but as application developers, lot of times application developers don't understand these isolation levels correctly, and that's why, and actually they are hard to understand, right? When we were reading these chapters, we realized that they were not so easy to understand, right? So that is another possible thing that could happen, that as application developers, we don't understand these isolation levels correctly, and we can make some mistake in our application, and we could have some subtle bugs which are hard to discover, right? So basically, overall, we have seen that there is a lot of scope of making mistakes, right? Uh, so so now, like, some of the things that we can do. Like, starting with end-to-end argument, right? So what are the things we can do? So uh, yeah, so here, so like one of the things is making immutable system, right? So by immutable system, we are saying that when we have some original source of data and we are making a derived system out of it, our original source of data should be immutable, so that if we have done any mistake in the processing logic and building the derived data system, then we can actually uh, fix that process. And because our original source of data is immutable, it has not changed, we can reprocess it and then build the correct derived system, right? Whereas, like, if we were building something like, we have this original source of logs, once we have processed this information and we have built a derived system out of it, we will delete these logs, right? Then we would be in trouble, because if our derived system was wrong and now we have lost our logs, right? So we won't be able to do that, right? Or if we are making in place updates and we are not doing immutable events, all those can cause issues, right? The other thing that we can do is exactly once execution semantics. And exactly once execution semantics is that a lot of times uh, we like there could be situations when like two requests are sent uh, for the same thing, because basically a user did not get acknowledgement, and so he thought that he needs to retry, although that process got successful on the server, so he will retry, right? But that he did not intend to do that transaction twice, right? So in all those scenarios, there are a lot of scenarios where we need these exactly once semantic, right? And so their idempotency is very important, that building the systems in idempotent way, right? And basically you would have to do some extra effort on your side to make your systems idempotent. They might not be naturally idempotent, right? So so why this thing is called as end-to-end argument of databases? So basically what uh, what the author wants to say is that, so these things like duplicates, suppression, and all those things, these are provided at the lower levels also of the network system that we're using. For example, TCP itself, it will automatically detect duplicate packets, and then it will like dedupe those packets, right? So similarly, like if we want to check integrity of data, that some bits have not flipped during the network transition and things like that, this TCP, Ethernet, and all, they have checksums which allow to check for the integrity of data, right? But these lower level systems, which are doing all those things for you to check your integrity of data, they are not enough. You have to end-to-end verify things, because there could be well a scenario where the packet was not duplicated on the TCP side, right? TCP has correctly duplicated and the packet was sent only once. But a user itself had made the request twice because he did not receive the acknowledgement. And so he is making that, right? So now it's up to the application to decide whether that kind of request could it, what are the effects of that request being sent twice. Could it mean that he wants to do it 2 times, or it means that he wants to do it 1 time? So that is something which these lower level abstractions, they cannot figure out because they don't know what behavior your application wants. So as the application developer, we have to decide and we have to build these systems, right?
So nowadays, when you're building the systems, right, the argument is kind of like a GUID or something.
What? Can you repeat?
Nowadays, when you want to build end-to-end arguments, right? Can you give an example for that?
So by end-to-end argument, by argument, it means that, so if you want to achieve exactly one's semantics, right? Then for exactly one's semantics, you have to do the duplication suppression by yourself by giving a unique ID to that request and all the way sending that unique ID to the database so that the database knows that if this request has been sent twice, it is the same request ID and it should not be repeated twice, right? So this is the case of exactly one's semantics. Then if you want to do integrity check, right? So by integrity check, what we are saying is that it's not enough to do integrity check on Ethernet level or on the network level. The source of data and the destination of data, like it could happen that on the network, there was no problem in the data and its integrity was maintained, but when it was stored on the hard disk, like because of some temperature or radioactivity or something, some bits flipped in the hard disk, and now your data is has lost its integrity, right? It has got corrupted or it's not correct or it has some wrong information. So you need to perform these checksums and all those things at that level also, right? So end to end, whatever was your like application wanting with the data and how it is stored, at a lot of places you have to do this end-to-end integrity checks on your own, and you cannot just rely on these, like these systems. They provide you some checks, but they cannot provide you all the checks because they don't know like what your application requirements are, and based on your application requirements you would have to do those checks. The other example is like these database provide you weaker transaction guarantees, right? So with weaker transaction guarantees, uh, databases want your they are providing you weaker transaction guarantees so that your system is highly performant. But now it is left on the application developers to ensure the correctness, right? Because with weaker transaction guarantees, you have to make sure that like whatever is expected from the system, you are aware of that, and that's how you are building the system, right? So yeah. So the second thing is enforcing constraints. So these constraints are a lot of times we have seen that we want to have uniqueness constraint, like only one username, right? Or we don't want to have negative account balance, or we don't want to sell more items than in stock, right? So how do we achieve this kind of enforcement constraint? So one of the ways is for uniqueness constraints, we remember that we have used consensus, right? That basically because that whatever is that unique value, you also need to replicate that unique value on multiple nodes, because if that node dies, then your system will lose that information, right? So you want to replicate and provide unique value as well. So you use consensus where you replicate to more than n number of nodes, and when all of them agree, then basically you store that value. So that is one of the ways to provide uniqueness, right? Another way to provide uniqueness is log-based messaging, which is like basically you are storing ordered logs of what events happened, and then consumers will read the log in that same order, exact order in which they happen, right? So which is actually total order broadcast. Total order broadcast is that all your events are totally ordered in the in some sequence, right? And total order broadcast, we have discussed, it is also equivalent to consensus, right? So these are the ways like consensus or these log-based messaging where you can provide uniqueness guarantees, right? Another uh, another thing that where you would want this to enforce constraint, but you don't have a single system, a multiple partition request processing system is, let's say if you want to do a payment transfer. So from account A to account B, and one account lives in one partition and another account lives in another partition, right? So like one way you would do it is that you would do a two-phase commit or the distributed transaction, right? But that would be expensive. So another way to do that without doing all these things is this using this log-based messaging. So by log-based messaging, you will follow these three steps. That if a user requests to transfer money from account A to B, you will give this a unique request ID and you will store this in the log, right? That a user wants to do a money transfer from account A to B with this unique ID. So you will store this in the log, right? Now, a stream processor will read this log and it will create two messages, right? So one is a debit transaction from account A and another is a credit instruction from account B, right? So then these, the consumers of this, they will read the stream and they will do the debit and credit. And basically they will do all the duplication and all and apply those things, right? So that is another way where you are basically enforcing the constraints without this expensive distributed transactions and two-phase commit. Any questions? Okay, so the other thing that is mentioned in the is now timeliness and integrity. So yeah, so this topic talks about consistency. So consistency, we can see it in the form of two ways, right? One is timeliness, where are you observing the up-to-date system or not? If we are reading stale data, but eventually we will get up-to-date data, then we are just temporarily inconsistent, right? And so basically the C of CAP, it actually means linearizability, that are you going to read your own write or not, right? Are you going to see the most up-to-date information or not? So that C means, right? The other thing is integrity, right? That is your data incorrect or not, right? So the timeliness is something that can be eventually fixed, right? But integrity is something which, if it is violated, it is permanent, right? And for most applications, integrity is more important than timeliness, right? So I said transactions, they provide us both timeliness and integrity guarantees, right? Uh, so again, now if we want to build these systems which are uh, which have integrity, right? So we are saying that it's okay to sacrifice timeliness, but it's important to maintain integrity. So how do we build these systems? So there are two ways to build the systems. So like if we are building any data flow system with integrity, means correctness, then we can use this log-based messaging, right? That we have discussed before. That basically whatever thing that you want to do, you stored it in a durable logs like Kafka or something, right? And then all the consumers are reading that information and then updating that derived information by reading those logs, right? And basically you will have the request ID for each of these so that you can make sure that you are providing item potency And also, you should make your original system immutable so that if your derived system was incorrectly processed, you can reprocess it, right? So these are some things you can do to make your system have integrity, right? Whenever you are building a derived system, right? Another path that we can take is that the constraints that we have discussed, we can loosely interpret those constraints, right? So, for example, if we said that for a restaurant table, only one user should be able to make a reservation. But if you made two reservations for two different customers, you can later fix it and apologize to the customer, right? And it could be acceptable in some systems, right? So this does not mean that these loosely interpreting constraint, they are these systems don't have integrity. They do have integrity, but the thing is they are not meeting the timeliness, right? Because they are not deciding at the same moment whether that constraint was allowed. When the system later processed the information, then it realized that two reservations for the same table are hampering with the integrity of the system. So I should let the user know that there is a mistake and only one of them, right? So now I have an interesting question. So we would think that these kind of systems are not great, right? Loosely interpreted constraints where we are later fixing the mistake and apologize, right? But do you see anyone has uh, any scenarios that what are the advantages of these kind of systems? So the advantages discussed here. Yeah, what?
Yeah, main advantage of loosely coupled systems is you can do deployments and everything is decoupled. You can add different levels of resiliencies on the systems based on deployments. All that can be easily scaled up, scaled down, and you can actually uh, better control over the flows. But disadvantages is you have to do lots of monitoring to make sure that as things get too much loosely coupled, the monitoring should be even more trickier and harder.
Yep. Yep. I agree. And hello.
Yeah.
Okay, I think someone else was saying something as well. Okay, so one of the things, and it's very interesting how the author has mentioned this is, so the other thing is that, uh, like, see, if you are not building a system which is loosely interpreting constraint, right? Which is like it ensures 100% ensures that if you are making a reservation, it will be consistent and you will get the table. Then basically, if it has to do some distributed transaction and all those things, then your system overall might not be highly available, right? Because it is making those consistency checks and all, and for that moment it might not be highly available, right? And like we have seen this with some of the banking systems and all where they are not highly available, right? So in those scenarios, when your system is not highly available because you want to ensure the strong consistency, you will still apologize to your customers uh, with in this way that your website is down, right? Your website is right now not available. You are not able to make this transaction and all. So what the author is saying that like you cannot make your apologies zero. Either you will make your apologies in the way that your system was less available and less performant because you were making your system highly consistent, right? And like immediately whatever information you are storing is up to date, or you could be apologizing by allowing some of the reservations to be made twice, but later fixing them and then apologizing. So yeah. So basically, these two approach where we are building these systems. Uh, so using these two way of loose link coupling without requiring coordination, uh, they still give us integrity guarantees, but they have like it will be eventual, and they have this appeal that they achieve better performance and they are fault tolerant, right? So that was about this. Uh, the last thing in this topic is trust but verify, right? So what the author is saying over here is that uh, like a lot of times we trust our systems, but just trusting the systems is not enough. We need to verify, right? Uh, so, uh, like, and some of the things that we need to verify is that we we need to be aware that like we need to maintain integrity of the systems in case of software bugs, right? That we have talked about. But other thing is that we cannot just blindly trust what the database vendors promise, right? Maybe they were saying something and they, in fact, they are also software systems. They have bug in them because of which we might have lost the integrity of our data, right? So we cannot just trust this database that we are sure this database will be storing information correctly. Like we have some scope of verification over there as well, right? So yeah, so basically we should have a culture of verification that we cannot just trust these systems, and we should be building our system design for auditability. Means like if we want to reprocess and verify and audit our systems, we should be able to do that. And the way we have discussed is immutable events. And then the last thing is end-to-end argument, right? Which is that we like we are building systems comprised of multiple components, and we know that we cannot trust every component 100%, right? So we must periodically check the integrity of the data and see if things are working correctly or not, right? So now I was saying that I can give some examples. So like basically when I was working on the project where we were making a search index out of the documents, right? So basically we had this similar kind of design which was at the top. Uh, right, so if you are making a search index, right? So you have built the, so you have some original source of documents, you are doing some processing, and all the changes to those documents go through a queue or something, and then you update your search index, right? So you have original data and your search index, right? Now we had to verify the integrity of our search index, because there could be some scenarios where these messages, like because of some bug or something, those messages were not sent or those messages were not processed, right? Or like there could be some scenario where like because of some issue the data got corrupted or something, right? Or any other issue, like you don't know what the issue is right now, and like later you might have that issue, right? So basically we had this reverse integrity check and forward integrity check, that for every document, for every source of truth document, like we would every 15 to we would run this job every 15 days or so, because it would be expensive job, that for every document which exists in the original source of data, we will check whether it is part of search index or not, right? And if it is not, then it will be, or if right. And similarly for every search index document, we will verify whether the document exists or not, because there could be some scenario that some delete event or something has been missed or something, right? And you
So
still have,
Abhishek, how are you building this search index? Are you using Kibana or Elasticsearch or
yeah,
something?
yeah. So we have our own internal systems. We are not using any open source.
Oh, okay.
Yeah.
And what technology are you using? Java, or is it like Cosmos or anything like that? Or
Yeah, so there are a lot of layers, but overall it's in C sharp. Like if you're talking about language is C sharp,
oh, C Sharp. Okay, sounds good.
right? So yeah, so we would also do the reverse integrity check, because like because we had our internal queue message processing system, uh, and because that could also have some bugs or something. So what if that queue actually misses some delete events, or it is not able to rightfully send that delete event to the search index, right? So actually that document has been deleted from the original source of data, but it still exists in the search index because that delete event never got propagated, right? Because of any bug or something. So that's why we run this integrity check every 15 days or something, so that the document which is part of search index, we will check whether it is actually in the original source of data, right? And so yeah, so overall, like running these periodic integrity checks to verify that your system, end-to-end system, has its integrity or not is very important, because right now you might think that all of your components are working fine and you don't have any bugs, but like later when you will realize that there was some issue, like there was some issue in the database vendor had some bug or something, then like you will be, like it will be harder to fix the things at that time, right? So yeah, that is about aiming for correctness. Any other questions, or we will move to the last topic? Okay, cool. So this is about like ethics, about how we are dealing with data. So the data, like many data sets, they're about people, right? They store their behavior, their interest, their identity, right? And that kind of data should be stored with humanity and respect, because the users of the applications that we build are humans, and we have to be very careful about human dignity, right? So like let's look at some of the examples where like we could actually unintentionally or intentionally uh, do some wrong things with the system. So one of the cases where we use a data system is for predictive analysis, right? Where we do large amount of data processing for predictive analysis, right? Uh, and like lot of them are useful, but let's say if a predictive analysis was made for something, that if a particular convict will likely re-offend or not, or if a person is likely eligible for home loan or not based on some prediction, right? So the decision that these systems are making, they have immediate effect on people's life, right? Whatever decision your algorithm is making, and that could have like lot of impact on that person's life, right? So it is very important to build those systems in such a way, keeping this mind that you are like these systems are going to actually affect people's life, right? And typically these systems, like if they are in doubt, they will say no, right? So basically, if a system thinks whether a transaction could be fraud or not, whether a credit card transaction should it be authorized or not, could it be fraud or not, if the system weighs it little bit on the suspicious side, it will say no, right? But then these systems, like they could have these unconscious biases and all. And so basically a user of these systems, if he has been rejected something, then like he's basically stuck in this algorithm prison where like you are talking to like you like that person, he does not know right who to blame. Like it's the algorithm, and that algorithm is not allowing him to actually do what he wants to do, right? So like there are three ways uh, where these predictive analysis create problem. One is this bias and discrimination. So like for example, if our algorithm was extrapolating some data from the past, and basically if we were saying that people who were living in this locality, they have like high chances that they will not repay the loan, or if they are belong to this race, they will not repay the loan, right? That's how the data was extrapolated, right? Then basically whatever discriminations that people have in mind, that has been actually codified into an algorithm, and that algorithm will also give it that discriminatory way, right? So a person who just happens to be living in that area or something, who is totally fine, who just belongs to that race, he might not be able to get a home loan or something, right? Because of bias and discrimination in our algorithms. The other thing is, when these kind of systems make these choices, then who will be accountable? Because if a human, if let's say a manually human was deciding whether you will get a home loan or not, then that human is accountable, right? He could be asked like what is the reason, at least he could be made accountable. But if an algorithm has made that decision, who will be accountable for it, right? Similarly, if a self-driving car is making an accident, like who will be responsible for it, right? So these are the things. And then because of this, a user could get stuck in a feedback loop. So imagine a scenario that your job hiring was happening based on the credit score, and you were a fine person, but somehow because of some reason you missed a payment and your credit score declined, right? Because you, let's say because of some issue you missed or something, now your credit score declined. Now you are not able to get new job because basically this job hiring system was based on the credit score. So now again you don't have job, so your financial condition is becoming even worse and worse, and so you are stuck in this feedback loop, right? So basically look at the impact of the algorithms these algorithms could have on a person's life, right? So that was about this predictive analysis. Another is about privacy and tracking. So the first predictive analysis talked about what we do with the data. This privacy and tracking is talking about the data collection itself, that when we are collecting the data, what are the problems with that data collection, right? Uh, so when these systems uh, they store data asked by user, right? Let's say if I'm intentionally asking a database to store some information so that it can remember it or for any other purpose, right? Then these are providing a service to us. But when the system stores my activity and store a lot of side effects out of what I was doing, then like we are not very clear whether they are providing some service to us, or do they have their own interest, or what is the reason, right? Why are they storing that other side effect information, right? So that is something that happen. And if some service is funded through advertising, like their main business is advertising, then the advertisers are their actual customers, and the users of their service are actually the second customer, right? They are the second interest for that kind of service, right? So in that case, you will see those kind of services will provide you free service, and they want to engage you as much as possible because their first customer is advertisers, so that they can provide better services to the advertisers, right? So these are the problems that we see with data collection, right? So we will quickly talk about 4 or 5 subsections in this. So one of the thing is surveillance. So the author mentioned that uh, just try replacing the word data with surveillance, because if if these systems, they're constantly tracking our activities and like and keeping track of everything we do, then basically they are not actually collecting data as such, they are also doing surveillance on us. So then read this statement, how this statement will sound like, and replacing data with surveillance. So a company is saying, in our surveillance-driven organization, we collect real-time surveillance streams and store them in our surveillance warehouse. Our surveillance scientists used advanced analytics and surveillance processing in order to derive new insights, right? So now see how scary it sounds, right? By replacing, and this actually happens. Like a lot of these organizations, they are treating data as surveillance, and this is what actually they are doing, right? So imagine, he said, just like to emphasize, just look, think of the title of this book as Designing Surveillance Intensive Applications, right? So how scary it sounds, right? But a lot of applications are being built like that. So like, and these affects a lot of our day-to-day life. So we would see that a lot of car insurance premiums and all, they and your health insurance claims, they will be based on the previous data that you have, right? And like maybe like these insurance coverage will be based on the readings from your fitness devices. The car insurance might have uh, information from the tracking devices in the car. So now when these surveillance devices are like making these choices based on the data, these these effects are not temporary, these effects are permanent. uh, because like imagine like these, and as like it was explained previously, like whatever effect they have, they stay with us for long. For example, if for some reason you had some health issue or something, then that will forever stay in your health coverage, right? And your insurance will be affected forever. So that like that system will then affect your life forever, because it is stored, that data is stored in these systems forever, right? Um, so the other thing is consent and freedom of choice. So these systems, they will often say that, hey, we have taken user consent, we have asked, we have shown them terms of agreement and all those things, and they have consented on, and they have consented. So it is okay to collect data, right? But think about it, that our users, they actually don't understand what we are saying in those terms and arguments, right? They don't understand how the data is being collected, what we are doing with the data. So most of them don't have any choice, but they accept it. And a lot of companies, they just obscure a lot of information, what they're doing in those long terms and agreements document, right? And the users have no choice but to accept it, right? And uh, maybe some users, small number of users who are privileged enough, they might decline using these services, who have knowledge to understand these services. But most of the common users, they don't want to miss out on the social participation and the professional opportunities they might get from these platforms, right? So they don't have any other choice. They like, either they don't use these services at all, right? Which might lead to them not getting jobs or something, right? So they have no choice but to accept these agreement documents and all, right? So the other thing is data as asset and power, right? So now this data, everyone wants it. It's not just these organization and advertisements, but even the government, right? And when we are building these applications, living in some country which is ruled by government, and right now we might think that this political environment is good or something, and it's okay to collect data. But we have also think about the future governments. What if the future government like create some rules or something that the company should also share the data with government and things like that, right? So there could be any possible scenarios, right? We don't know like how the new government is going to respect human rights and civil liberties, right? So that's why uh, like data is like it has a lot of power, and we have like everyone wants it, right? And now not just these governments, like these companies, right? The technology companies that we are using today, they are just involved in the technology aspect. They are not into the political grounds or something. But imagine if these companies, like few years from now, they start seeing the political angle and they get involved too much in the politics or something. So now we could have handed over like our data to that one political organization. So as developers of these organizations, we should be careful about that, right? Uh, Then the other part is legislation and self-regulation. So a lot of that's why lot of places they have these data regulations. Like Europe has European Data Protective Protection Directive, but then the company who collect these data, they will oppose these regulations, saying that they are a burden and hindrance on innovation, right? And these companies are also not totally incorrect, right? For example, if a medical data is being processed and shared, right? It has risk to leaking the privacy on all those information, but it also has a lot of potential opportunities. Mining that useful data could help better diagnose the disease based on those strengths and all, and could save a lot of lives and a lot of deaths by making wrong diagnosis, right? So like there has to be some balance. Like over regulations can also prevent such breakthroughs, uh, but misusing the data could also have some effects, right? So yeah, so it's important to maintain this balance. So yeah, so the overall advice that's mentioned in the end of the book is that we need a cultural shift in the tech industry with respect to personal data. We should stop regarding users as metrics to be optimized and remember that they are humans who deserve respect, dignity, and agency, right? And basically, we should be we should allow uh, each individual to make their own decisions with the privacy. They should have their own control about what they want to do with their data. They should be allowed to remove any previous history of the data that a system has stored, right? They should be given, and we are seeing that some companies are following it. Some companies are starting doing this, that users would be allowed to delete any data they want. So, uh, yeah, and basically, as the systems itself, we should also not retain the data forever, but purge it as soon as it is no longer needed. Right? Yeah, so that was it on this chapter and on this book. Uh, yeah. So, any any questions or anything someone wants to add?
Yeah, the key data to surveillance, that is the key, right? That is actually not a thing of the past, but it's actually happening right now. That's why last year European Union and California came up with CCPA and European Union kind of thing. Any product that you see, it's free, like Yahoo or Google or Facebook or LinkedIn. You should expect that your data is sent, at least the metric side of it. WhatsApp or even this, right? Discord or Zoom, anything that you see free, your data is getting shared. Assume that you have very less control over what metrics is is kept private. Only thing with CCPA only from California and Europe, they have control that they can go to any company and say, don't keep my personal data. Other states, they don't have that, or other countries. So your data is 100% harvested by them and sold to other companies.
Yeah,
So that is a very key point.
yeah, definitely. Thank you so much, Praveen, for adding this. Cool. Okay, so I'll stop the recording and